Bismillahirrahmanirrahim. Today I will be explaining the numericals in detail. Today we will be doing with the chapter that is probably simple machine of class 10th. As you can see, there are 6 numericals in this chapter. So one by one I will explain these numericals in detail. So the first numerical is like an effort of 160 Newton applied to a pulley system is able to lift a load of 750 Newton through a vertical height of 1.2 meter. To do this, the effort moves a distance of 7.2 meter. Calculate the mechanical advantage of the pulley system and the efficiency. So what we have to do is here we have to calculate the mechanical advantage, as the mechanical advantage is written as m dot a and the efficiency. So what we have to do is, class, we have to make the data. So for that what we have to do is we will be making data like problems. Today we will be doing with the problems, and that is chapter number 9 probably in the old book, and chapter number 1 of the new edition book. So given data, what is given is we are given with effort, which is denoted by P is equal to how much? 160 Newton. And we are given with load, that is W is equal to 750 Newton, and we are given with height, that is 1.2 meter, and we are given with the length, that is 7.2 meter, and we are supposed to find. What we will do is here we have to do like to find. So in to find we have to find two things. Number first is mechanical advantage. As I already told you, mechanical advantage is written in short form m dot a, and number second is efficiency. So we will be using formula. So what we have to do is, for mechanical advantage formula, what is the formula to find mechanical advantage? To find mechanical advantage we have formula like W upon P. So here W is what? Weight, and P is effort. So we will be putting the values. So W is 750 newtons. So as I'm doing it again for you, 750 newtons, and effort is like 160 newtons. So Newton will be cancelled with Newton, 0 will be cancelled with 0, and after calculating from calculator, 75 divided by 16, we get the answer, that is 4.7 after round off. So this is the value for what? Mechanical advantage. So some of you may be asking in this question like, what is the unit of mechanical advantage? So there is no unit of mechanical advantage, as it is the ratio of two things. So Newton and Newton gets cancelled out, so that we do not have any ratio. So now we will be doing for what? For efficiency, right? So for efficiency, as I'm doing it over here, efficiency. So for efficiency we have to use the formula. So the formula is like E is equal to output divided by input multiplied by 100. So first of all, what we have to find is we have to find output. So to find output, we know that the formula is W multiplied by H. How we will remember this formula? It is like W multiplied by H. So W is how much? W is 750 Newton, and height is like 1.2 meter. So when we multiply these two, so what we get, the answer is like 900 newtons. fine. So sorry, 900 joule. So when Newton and meter multiply, it becomes joule. So output is how much? I'm writing over here. Output is equal to 900 joule. So this is for output. Now we will be doing for input. To find input, we have formula. It is P multiplied by D or P multiplied by L. So what is P over here? P is effort. The effort is 160 multiplied by 7.2. So after multiplying these two numbers, we get the answer, that is 1152 joule. So this is input. Now we will be putting the values in the given formula of what? Efficiency. So that is output divided by input multiplied by 100. So putting the values, output, we have output like 900, and then we already got the answer of input, that is 1152 multiplied by 100. When we calculate these all values, so what we get is, after calculating from calculator, so we get the answer, that is how much? 78.3%. So this is the first numerical as we did with it. Now we will be doing with the second numerical, that is the ratio between the length of the arms of a lever is 4:1. How much force be applied to the longer arm so that a load of 20 Newton suspended at the shorter arm can be balanced? So this is the second numerical. So now we will be making data for the second numerical. What we have to do is, we will be first making data for the second numerical. So as we can make data like this one. For example, this is a lever, and over here some weight is lifted, and over here, so this is what? This is called effort arm, which is denoted by H, and this is called weight arm, which is denoted by L, and we can also name the points as ABC. So this is fulcrum. So now we are given with what? Given data. So as this is the numerical number 2. So given data, what is given is, we are given with L ratio H, that is how much? 4:1. So it can be also written as L over H is equal to 4 over 1. W is given by 70 Newton, and we are supposed to find P. We know that for ideal machine output is equal to input. So output is what? W multiplied by H, as we know that, and input is P multiplied by L. So after rearranging, so what will happen? This will happen, and then we have to put the values. What is W? It is 20. And what is P? We have to find the value of P, and then what we have to do is putting the values. After putting, we cross multiply. By cross multiplication, what will happen? 4P is equal to 20, and 4 is since multiplying over here, so when we take it to the right side, what will happen? It will be divide. So after dividing 4, we get 5 Newton. So this is the answer of effort. So P is what? As I already explained it for you, this is effort. So effort is equal to P is equal to 5 Newton. Now we will be doing with the third numerical, that is probably an object of mass 100 kg is raised 2 meter above the ground using an inclined plane of length 10 meter. Calculate the effort applied parallel to the inclined plane. Again, we are here, what we have to find is effort. In the previous numerical, we were supposed to find effort, and again here we are supposed to find the effort. So effort is denoted by P. So now we will be making data. First, before making data, we have to know the diagram very well. So this is probably third numerical. So an inclined plane is probably drawn like this way. It is subtended to the ground, and it is making theta with the ground, and here we are lifting some load. This is a load, and we are lifting, and W is always acting downwards, and we are taking the load to upwards, right? And we are supposed to find P, how much effort is applied to this load to uplift to some distance, and mass of this load is how much. It is 100 kg. And what is the length of this inclined plane? It is probably 10 meter, and this is height, and height is given by 2 meter. So I hope now this diagram is clear for you. Now we can easily make the data. So what is data for this numerical, students? We are given with mass, which is denoted by m, as already we did over here, 100 kg, and we are given with height, that is 2 meter, and we are also given with length, that is 10 meter, and we are supposed to find what? Effort, that is denoted by P. So now we know that for an ideal machine, output is equal to input. As we already know that what is output equal to. Output is, as I already told you, the technique, that is W multiplied by H is equal to P multiplied by L. So output is equal to W multiplied by H, and input is equal to P multiplied by L. So what is W over here? Some you might ask. So for W, we will be doing it over here. W is basically is equal to mg, right? So when we put the value of W over here, it becomes mgh is equal to P multiplied by D. We know that W is equal to mg, weight is equal to mg. So now rearranging for P, we have to find P. So P can be retained over here in the right hand side. So what will happen with L? So when L comes to this side, so it will divide, since it is multiplying here, so this will happen. So afterwards, what we have to do, we can also write it like this way. Now we will be putting the values. So what we have to do, M is given to us, that is 100. G, what is the value of G? Some of you might ask questions, so I'm writing it over here. G is equal to 9.8 meter per second square. So I'm putting the value of G over here. It is 9.8 multiplied by, what is H? H is 2 over here, so I'm putting 2. And what is L? L is 10 meter. I'm putting 10 in place of L. So now we will be calculating the values. So the final target is to calculate the values. What will happen? 0 will be cancelled with 0, and now I am calculating for you. 10 multiplied by 9.8 multiplied by 2. As you can see over here, after calculating, I got the answer, that is 196 Newton. 196 Newton. So this is the final answer, as this is the effort. So students, hopefully I will be coming up with the second part, the 3 remaining numericals in the second part. So stay tuned to become connected to the 3 remaining numericals. Thank you.